Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the today's session, I will discuss the question which was asked in the GATE 2025 engineering science paper from the solid mechanics. So this is the fifth question of the GATE 2025 XE series. So I have already covered the four questions from the GATE 2025 XE part. So those who have not seen, so please watch that part 1 lecture also. So the fifth question is, a pair of force P of 100 Newton are applied to the handles of plier as shown in the figure below. Neglecting the friction, the force applied by the upper jaw on the workpiece, you have to calculate, and that value you have to enter in the integer. Okay. So basically, you have to calculate the force exerted by this upper jaw on this particular workpiece. Okay. So in these type of problem, what you will do, first of all, you will draw the free body diagram. Okay. So free body diagram means whatever the force is which are acting on that member, you have to apply those forces. So let me first draw the free body diagram of this particular member. So I'm taking a bottom plier. So the force acting at this point is nothing but 100 Newton, which is given in the question. Now there is a hinge joint. So at the hinge joint, you already know there will be the two reactions. Let us suppose the reaction will be, let us suppose I am considering this point is O. So the reaction will be, this is Rx and this will be the Ry. Okay. So the reaction in the X direction and the reaction will be in the Y direction. Now there is again one more contact between this particular handle of the plier as well as the workpiece. Okay, the upper jaw as well as the workpiece. That means whenever there is a contact, that means there will be a normal reaction. Let us suppose that normal reaction is R. Okay, then the distance between the center point O to this particular contact force on the normal reaction is 25 mm. And this distance, which is given as 100 mm from the point O to this particular point. Let us suppose this point is A. And this point I'm assuming as a B. Okay. Now, what you will do, you have to calculate this normal reaction or the contact force between this workpiece as well as this upper jaw. Now, if you take the moment about O point, so take the summation of moment about O point, which is equal to 0. So what are the forces which will create the moment? One is this force and another will be this force. Yes or no? Because if you take the moment about O point, these two reactions are passing through the hinge joint only. Okay, that means the moment of these forces will be 0. So the moment about O point is nothing but P into force into perpendicular distance, which is nothing but this force will creating the moment in this direction and this reaction will create the moment in this direction. So I can write this P into 100 minus R into 25 is equal to 0. And the P value, which is already given, 100 into 100, which is equal to R into 25. That means the R value, if you solve, then you will get as a 400 Newton. And that force you have to find out. So the correct answer for this question is R is equal to 400 Newton. And that is nothing but in integer. Okay. So the next question, which is basically from the vibration. So what is the question? In a spring mass system, the natural frequency is 10 radian per second. So there are the four options given and one statement is given. In a spring mass system, the natural frequency is 10 radian per second. For that, you have to identify which option will be the correct. Okay, so this is basically a MSQ type of question. That means more than one answer will be the correct. Which of the following option is slash R are correct. The first option is the spring stiffness is 1 Newton per meter if the mass is 100 kg. So you have to calculate the natural frequency. It is coming out to be equal to 10 radian or not. If it is equal to 10 radian, that means this option will be the correct. So you have to check each and every option. If the natural frequency is coming out 10 radian per second, then that value, that option will be the correct one. Okay, so let me start with the first only. So if you take the natural frequency is nothing but the stiffness divided by mass. Okay. So if I will consider the first point, that is the A option. So what is the natural frequency in case of A option? The spring stiffness is given as 1 and this value is given as 100. That means if you solve, then you will get 0.1 radian per second. Okay. Then option B, natural frequency is equal to, the K value is 620 and the mass is given as 62. That means this value is nothing but root of 10, which is equal to 3.16 radian per second. Now the C option is, the spring stiffness is given as 620 Newton per meter. That means the natural frequency is, the spring stiffness is 620 and the mass is given at 6.2. So if you solve, then you will get as a square root of 100. That means this value will be 10 radian per second. Okay. So which is matching with the this results. That means the option C will be the correct one. Okay. Now, then one more option is left. So please check that one also. So the natural frequency is square root. What is this value of K? 125 divided by mass is 1.25. Again, if you solve, then you will get 10 radian per second. 10 radian per second. That means out of these four options, the C option and D option is basically giving the natural frequency as a 10 radian per second. That means the option C and option D is the correct answer. So the correct answer for this question is choice C and D. And this is a MSQ type of question. That means more than one option will be the correct. Okay. So move to the next question. What is the question? A ball of mass 5 meter, which is approaches with a velocity of 2 meter per second from the left to right towards a stationary lighter ball of mass m. Okay, that means there are the two balls. One ball having a mass 5m. Okay, the another ball having a mass of m. This ball, which is having a 5m mass, it is moving with a velocity 2 meter per second and it is moving from left to the right one. That means let us suppose this is one ball which is having a mass of 5m. Okay. And this is the another ball having a mass of m. Initially this ball, okay, that it is already mentioned, the lighter ball of mass m, which is at the rest condition. That means let us suppose the initial velocity I am assuming of the second is u2 is 0. Okay. And this u1 is given as 2 meter per second and it is moving in this direction. So it is approaching towards the lighter ball. Then what happened? The collision between the ball is an elastic central impact. If the velocity of heavier ball after the impact is 1 meter per second in the direction left to right. Okay. So what is the situation after the collision? Let us suppose this is the before collision condition. Before collision condition. And this one is the after collision condition. After collision condition. After collision condition. Before collision condition and the after collision condition. Okay. Now, after the collision, the velocity of heavier ball means this 5m mass of ball, after the impact, its velocity is 1 meter per second. So this velocity, let us suppose v1 having a mass of 5m, which is moving with velocity 1 meter per second from left to the right. Then this mass of ball, which is nothing but m, you have to calculate what is the velocity after the collision of lighter ball. That means you have to find out the velocity of this ball whose mass is m. Whose mass is m. Okay, so what you will do in this question? You just apply the conservation of momentum. Very simple question. Conservation of momentum. Conservation of momentum means, so the momentum before the collision is equal to momentum after the collision. So m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay, so the m1 mass you already know, which is given as 5m. u1 is the initial velocity, which is given as 2. Okay, so the second ball having mass is m, and it is at the rest condition, that means zero velocity. So again, this is 5m and this is 1. This is m, and the v2 you have to calculate. Okay, so this is nothing but 10m, 5m plus m into v2. So what you value you will get as a v2? V2 is nothing but 5 meter per second. 5 meter per second is the answer of second ball. That means the lighter ball which is moving with velocity 5 meter per second, and its velocity is positive, means it is moving from left to right. Left to right. Okay, now see the options which is given in the question. It is continues to the rest, wrong. Moves with a velocity of 1 meter per second left to right, this is also wrong. Moves with a velocity 5 meter per second left to right, yes. The option C is the correct answer. The option C is the correct answer. So choice C will be the correct answer. Okay.